Here's a recap on how to take one shape and place it on top of another shape to prove that the two shapes are similar. We've done this before with congruence, and there's 2 videos on that already. What I want to do here is take this shape right here, quadrilateral ABCD, and get it to land on top of this larger shape right here. Well, I just said a key word right there. I need to make it larger. So one way to do that is to begin with a dilation. And I got to decide how much times bigger do I have to make each length. Well, one part of the picture on the right that's easy to see is that between A and C it's 4 spaces long, and between A double prime and C double prime it's 8 spaces long. So I have to make the shape on the right 2 times larger than the shape to make it match the shape on the left. So that's how I decide that to begin for this question. I'm going to start by doing a dilation, capital D, a dilation of 2 on shape ABCD. When I do that, it'll multiply those coordinates by 2. So point A started at 1, 4. If I dilate by 2, it'll turn into a brand new point. We'll call it A prime. And dilating by 2 multiplies the coordinates by 2. So A prime would map onto 2, 8. And that's a good thing, because you can see that the A's are equally above the x-axis. Point B begins at 5, 2. When I dilate it by 2, the brand new B becomes 10, 4. So 10, 4 places the new B over here. And C was at 1, 0. When I dilate it by 2, it turns into 2, 0. So the brand new point C would end up right there. If I connect those together, I got the beginning of it. I just need one more point. Point D is currently at 2, 2. When I dilate it by 2, it would turn into 4, 4. That would be the brand new D. Alright, so these are almost exactly where I want them to be. The only problem is the shape on the right, in white, is in the wrong position. I want to actually get it into superposition and make it go onto the shape on the left. To do that, notice that these are mirror images of each other. So to get them to go on top of each other, I'm going to have to reflect. So I'm going to add on one more step. The circle that I'm using right here is a composition dot right over here. And that's saying that I'm combining this dilation with one more move. I'm going to combine by a reflection to lowercase r over the y-axis. So a complete description of what happens to get ABCD to turn into A double prime, B double prime, C double prime, D double prime is to combine a dilation with a reflection. In this case, it could be done in either order. And if I really wanted to throw a little extra bit to this for style points, I could actually show that I'm changing A, B, C into A double prime, B double prime, etc. like that. This is very, very good work. If I wanted to be even more professional about it, I could add on the center of the dilation here. Since I multiplied the coordinates by 2, I'm actually using a center of dilation at 0, 0, or the origin. So I could write that down next to this D. How do I know that the center of the dilation is the origin? Well, one way is to actually draw in lines that connect the image with the pre-image. And when I do that, all four of those lines end up meeting at the same point right here, the origin. For a question like the one on the bottom here, this one's a little bit more complicated because it is not on a grid or not on a piece of graph paper. If you read the directions over, it says I'm trying to show that these two triangles are similar to each other. That's what this symbol means here. I want to show that these two triangles are the same shape but a different size. And one way to do that is to take one of these triangles and place it on top of the other triangle by using a series of transformations. If I can do that, I've proven that the two triangles are similar. So in order to do that, I'm going to have to do some moves or some transformations to get the shape on the right to land on the shape on the left. And this is one thing that can be done. So just stick with me on this. I need to get these triangles to land on top of each other. Maybe the quickest way to do that is to draw in a perpendicular bisector. There's more than one way to do these. If I drew in a perpendicular bisector that separates B from E equally, and it's perpendicular, I can use that as a line of reflection, I'll call it line L, to take the triangle on the right and place it on top of the triangle on the left. When I do that reflection, it's not a perfect reflection in terms of making this triangle land exactly on top of this one, because this triangle is smaller than that. But this is maybe the fastest way to do this question. So I'll do this in white. I'm going to take the white triangle here and reflect it over the line L. When I do that, it will land just about like that. If I want to call this a brand new point, I guess I could call it F prime. I would call this point D prime. And E ended up going right on top of B. So I'm taking the triangle on the right, flipping it to be in position there on the left. So the last thing would be to take the white triangle and make it larger. But as you can see, there's a problem here because there aren't any numbers. So if we want to make it larger, we need to come up with a way to describe the scale factor that's happening here. So if we're going to try to figure out the scale factor, it is helpful to figure out which one is the pre-image and which one is the image. We're trying to turn the white triangle into the black one. So we'll call the white one the pre-image, the black one the image. And the formula for scale factor is the scale factor is the image divided by the pre-image size. Without any numbers here, it's impossible to come up with the answer to this question unless you measured, and even if you measured, there'd be some flaws with the ruler. So what we'll do instead is use the letters to help us describe the measurements. So I need a measurement on the image. Why not take AC? So I'll write AC. And I need a matching side on the pre-image to go underneath in the formula. So AC matches up with D prime F prime. And that's what I'm going to have to dilate by. So to recap the entire answer, what you'd have to write out is that you're taking triangle FED and beginning by reflecting over line L, and then combining it with a dilation. Well, the center of the dilation ends up being point B. So that's what would go down here. And the amount that we're dilating by is our scale factor. So we would write down below here, we're dilating by AC over D prime F prime. There's the answer. To help you along a little bit with the homework, those examples that I showed can help with the more trickier ones that are near the bottom. Let's go through two of them on the bottom here. One that's kind of easy and one that's kind of more complicated. Let's go with 31. First of all, one that's maybe more on the easy side. It says to determine if it's an enlargement, a reduction, or congruence transformation. So this question here, 31, which one is the image? Which one is the pre-image of these two shapes? Well, the pre-image doesn't have any prime symbols on it. So, write that down on your paper. That's your pre-image. This is your image right here. In this question, they want the scale factor. So the scale factor is a length of the image divided by a length on the pre-image. So this one's actually pretty easy. A length on the image, we could pick any part of the image and find out how long it is. The easiest part of the image to find is the distance between I and J prime. It's only 2 spaces. So it would be a 2 for the length of a part of the image. I need the matching side on the other triangle, on the pre-image. It's from J to I, and that's 4. So the scale factor is 1/2, which makes total sense because the image is half as long as the pre-image. All right, let me take you through maybe one or two of these. For question 33, we run into a problem because there's no numbers, and there's really no numbers that are easy to actually calculate. Decide which one is the pre-image and which one is the image. So to find out which one's the pre-image, we're looking for the one that's plain. QTSR. It doesn't have any prime symbols. That's where we are beginning, and we're finishing up with the one that has the prime symbols. So this would be the pre-image here, and this is the image here. To figure out the scale factor, I'm using that formula. The scale factor is a length of off the image divided by a length off the pre-image. Looking at the image, there aren't any real easy distances to find because all of these segments are going diagonally. And some of them are actually meeting in a very odd place, like over here. So, how can you find out how far it is from here to here? You can't do that by counting. Even if you look at point Q prime, it's someplace not even on the grid, it's someplace above here. So I'd say it's impossible to find out any of these lengths here by the way that this is shown. So since that's the case, even though it's on a grid, we're limited. So what we have to do is actually come up with letters to represent the distances. So we need a side off of the image. Why not use Q prime R prime. That would be our side off the image, Q prime, R prime. The matching side that goes along with this is this side here, QR. So if you were going to call this something, you would call this, if you were going to give this a title in terms of what the story is here, or what this question is all about, this one is a dilation, using the center of the dilation as point C. And how much are we dilating by? We're dilating by the length Q prime R prime over QR. Very, very different and not so easy to do when you're not given any numbers. All right, well, one more question would be a good idea to show the answer to. Question 34, I might as well look at its next door neighbor right there. For question 34, I want to try to figure out the scale factor. So I need a side off the image divided by the side from a pre-image. Looking at these two triangles here, the white one is definitely the pre-image because it doesn't have any prime symbols on it. And the smaller one is the image. So I need a length off of the image. Looking at that triangle right there, do I know any of the lengths? Can I find any of the lengths of this triangle? With the way that these are going diagonally, I cannot count those. And since I might be able to use the Pythagorean theorem, believe it or not, but I don't even know how far this is here and here to be able to use a Pythagorean theorem. So what I'm going to do is the next best thing, is I'm just going to use the letters that are there. X prime, Z prime is one side off the image. So X prime, Z prime. And I need to find the matching side for X prime, Z prime. And because this is labeled nicely with X's and Y's, in the pre-image I'd be matching that up with XY. Now, what's tricky about this one is that the pre-image and the image are rotations of each other as well by 180 degrees. Because they're not pointed in the same direction, the scale factor in this case would actually be negative. So that's a nasty question to be able to figure out. By me showing you one that's this nasty, I've actually taken it to the top of the mountain. That's about as brutal as a question that you could possibly run into without the numbers, dealing with it like that. So good luck, and keep on using these videos to watch and replay if you need to. Remember, the after-school help is available, and hopefully these videos do make a difference now and then before you're getting ready for your exams.